Hey folks, Quill18 here, and welcome to what will hopefully be a relatively quick tutorial on how to make an infinitely scrolling background for your Unity games. This works in both 2D and 3D, and it's the sort of thing you see a lot in space games, but can kind of work in everything. I'm going to be starting off with an empty project here, except that I've gone ahead and imported a seamless star background texture that I grabbed from OpenGameArt, great website that you should check out if you want some great art, I guess. Anyway, so I just did that because I can't art, so I figured it would be easier to bring that in. The defaults of this project is set to 3D, but it doesn't really matter. Note that you can use this in a 2D project, but this this background thing, you're not going to use as a sprite. You're just going to bring in as a regular texture, not as any sort of sprite kind of system over here. Okay, just the texture. So in our scene, what we're going to do is we're going to create a quad. We're going to create just this flat plane to use as our background that's going to represent our Starfield. Now, we're going to use an actual quad as opposed to a plane. The difference between a plane and a quad, if we bring up the plane and then sort of zoom out here, you can see the plane's got quite a lot to its mesh, and we don't need that kind of detail. It's really a waste of resources to use something that intense, whereas we can just use a quad, which is literally a single rectangle. Now, if you do note with your quad, it's only visible from one side. It's only rendered on one side. It's super lightweight object. One thing to consider will be your orientation of your camera in the game world. So right now, the default camera faces, it's got no rotation, so it faces forward into the Z-axis, which means your quad, you're going to want it standing up like this. But if for some reason you have your camera turned to be facing down instead, which is to say a negative on the Y-axis, and for the camera to be above the scene, then obviously you're going to want to go ahead and rotate that quad. For our purposes, everything is fine. I'm going to make sure that everything is centered, though. I'm going to leave the camera at -10 on the Z-axis with no rotation. The quad, I'm going to make sure to center. And what I'm going to do is I'm going to make the quad big enough to cover the camera. Obviously, this is going to be very dependent on your camera's distance from the scene and perspective level, or if you are in, perspective level, I meant field of view level. If you are an orthographic projection, which is much more common in a 2D scene, then it's going to be entirely dependent on the orthographic size over here. So I guess we'll stick it in orthographic. I think that makes perfect sense. And with the size of 5 on this camera, that means it's a distance of 5 world units from the center of the screen to the top. Our quad is, I think, starts off at a size of 1 by 1 or maybe 2 by 2. We increase it to 5. Yeah, so we're going to have to go 10 and 10, and that actually doesn't cover our width. So we'll just stick it to, actually, I'll leave it 10 by 10 for now so we can show it. Actually, I'll leave it smaller. Tell you what, I'll put it 8 by 8 so we'll clearly see the borders of where the quad is. But you're going to want to like fiddle with these sizes, and this is, it's a little bit tweaky to have to do it that way, but it's going to be fine. The next thing we're going to do is we're going to create a new material. So in our project view, we can use the create button here, or we can just right click anywhere in the view here as well. That's a fine way to do it. And we're going to go ahead and create a material. And we're going to call this our Starfield material, I suppose. Now, a few things. First of all, in our material, we're going to want to go ahead and bring our texture into our material. And then we're going to want to assign this material to our quad, right? Our quad has this mesh renderer, and it's got the materials over there, and it's got its default one, which is why it's gray. So we can assign the material a few different ways. We can just drag it onto the object, which will set it, or we can put it in this field here, or you can just use the little circly, targety thing here and pick your material that way. So now we've got it, and you can see the Starfield, but it's quite muted. The reason is the default diffuse material uses lighting in the scene, and right now we have no lights in the scene whatsoever. There's a tiny bit of ambient lighting, which is why you can kind of technically almost see the stars. I mean, it's a little bit better if we zoom in over here, but it's hardly so. If we do drop a light in a scene, we're going to be able to see it better, but we're going to see that the behavior is not exactly what we're looking for. Let me just zoom out here so I can see there, and the quad is there. Okay, so if I pan around this light, then the light is obviously lighting our texture, but you're not going to want your stars to be lit up by lights on spaceships or something. That would be weird. That makes no sense. So clearly, this quad, this material, our Starfield, should not be affected by lighting whatsoever. In fact, it should light itself. And you might think that the thing to do is to grab the self-illumination shader, which would work. If we go self-illumination diffuse, it'll be nice and bright as it provides its own lighting. But really, this is a slightly more complex shader than we need because it uses its lighting based on a texture, and it will default to just blah, 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 blah. We're not going to use self-illumination. We're going to use unlit, which sounds like it might just be dark. But what it means is this shader is so simple, it ignores all lighting whatsoever. And you can see visually it looks exactly the same, but the shader info over here is is simpler, and it's just a much more lightweight shader. So it ignores lighting, everything is just fully lit on it all the time, and it's exactly the kind of effect we want. So now the next step is, how do we get this thing to actually scroll? Well, what you want to do on your material, which you can access from your object or from here. Now, note that these are linked. If I say change the tiling, let's make it tile 3 times in the X, and 3 times in the Y. So now it's sort of everything shrinks and it repeats more often. If I go and check my material over here, it's actually changed it. That's because by default, objects in Unity use a shared material. So if I go, and let's say I make a duplicate of this quad, and then turn my view, and then grab this guy over to the side. If I make changes to one of them, it affects them both, which is the same as editing this guy over here. Once you're in the game, you can break that link. In the editor, you can't. If you wanted them to be able to be editable separately, you'd have to make a duplicate of your material, assign one material to one material to the other. So we just need the one quad right now. So you know what tiling does. It's pretty obvious. It just repeats it in a certain direction. But the thing we're going to play with is offset. Now, an offset will actually just shift everything over. So this X offset, if I put in a 0.5, what will happen is it'll move everything over half. Or 0.1 is like even nicer. I can go to 0, 0.1. You can see, watch like say these stars over here as I put in the 0.1, they'll move to the left. Oops. 0.1. See that? They move left and right. If I put in a value of 1, nothing changes. And that's because that's the looping. It loops from 0 to 1. So a 1, 2, 3, every whole number is exactly the same as a 0. So there you have it. So what we're going to do for infinite scrolling, what we can do is we can just play with these offsets here. So let's make a simple little script. We're going to create a script in here called, I don't know, scroll UV. Okay? Scroll UV, and then we're going to go ahead and apply it to our quad. And the job of this script will simply be to change these offset numbers, but slowly in a sexy kind of fashion. So all we need for this is an update, and you'll probably want to do this in an update as opposed to a fixed update, because you'll want the stars to update based on every rendered frame, not based on every physics tick. You want it to update as quickly as possible, so we're going to do it in there. And what are we going to be modifying? Well, we know, we can tell here. We've got this material. Well, where is this material? It looks like its own component, but it's not. This here, because again, if we're editing this, we're really editing the prefab. This is a convenience thing. It's not its own true component. It's a convenience thing that is a factor of the mesh renderer. If we remove the mesh renderer, we're going to lose this little bit over here. So the materials actually belong to the mesh renderer. Okay. So we can access that. We can say get component mesh renderer. We know we have a mesh renderer. In fact, I think there's a shortcut on here. If we can go like this dot renderer. Yeah, we have a renderer component, which is a shortcut to that. But let's be explicit. In fact, I'll be super explicit. I'll save everything in local variables, even though we don't have to do that. So mesh renderer, MR equals, we're going to get our component called mesh renderer. And you don't need to be as explicit as I'm being here, but it'll be clear. On our mesh renderer, we have a variety of things with the word material in it. So what's the difference between materials, shared material, and shared materials? Shared material is by default what's going on in all these objects. Again, we noticed how one quad, when we make a change here to the material on the quad, it changes the material in the project. So it affects everything that uses that material. That's what the shared material is. If we make a change to the shared material, it'll affect everything that uses that material. So what is material? Material is my personal copy of this material, and if I make a change to that, it only affects the material on this specific renderer, which is to say this specific object. And what Unity does is it's pretty smart. If you make a change to the material, then it sort of breaks that connection between the shared material and material. You can do a few tests back and forth and see exactly how it goes. So I think for our case, it makes sense for us to tweak just our material by itself and play with it scrolling. So let's grab a copy of this. So we can get material mat equals. Now, there were two of them in here. If you remember, there's material and materials, right? Well, if you take a look at your renderer actually has an array of materials on it. You can give it multiple materials. Some objects, one mesh will reference multiple materials like that. It's not super common, especially at low levels of Unity, but it can come up more and more later on. In our case, we only have one material. So we can access this via the materials array. And if we want to grab the first one, it would be the index of 0. Material is just a shortcut to that very first entry. So for us, I think that makes perfect sense. So we've grabbed a copy of our material. Now what do we want to do to it? Well, the material has something called the texture offset. Okay, get texture offset, main texture offset, set texture offset. These all kind of work together. The idea is for get and set texture offset, you have to give it a property name. Now, by default, the main texture, the one this object only has one texture. In fact, most materials only have one texture on them, or at least a lot of the basic materials. It's called main text. So this get texture offset main text is, or at least should be, exactly the same as just accessing main texture offset. Now, you'll notice that this is a vector 2. Okay, whether you get it or whether you just access this one, which is a handy shortcut, it's going to return a vector 2. So we know in C# you can't add vector 2s directly. So we definitely, for this one, have to grab a copy of it. This is the offset. We definitely have to grab a copy of it and then make a change. And what kind of change are we going to want to make? I don't know. We'll say the offset x is goes up by time.delta time. Then what we want to do is feed that back into the material. Texture offset, and we save that change back in. I think this will update it. It's possible we have to write our material back. Let's go ahead and give it a quick test and see what happens. Oh, there we go. Perfect. So we are changing the main texture offset on the material that belongs to our mesh renderer. And you can see here it's scrolling at a rate of the entire thing will make one full loop every second right now. We could slow it down by dividing this this delta time, by this. Now it'll take 10 seconds to go through a full loop. Oops. Play. You'll do that. Now we're just offsetting the X, as you can see here. Oh, I forgot to, I'm terribly sorry. I forgot to make this text bigger. Terribly, terribly sorry about that. You can see here, it's the X value gets changed. It goes nice and slow. It looks really cool. You get kind of a cool Star Trek-y kind of effect. Obviously, you're going to want this quad to be big enough to cover the entire view. You can write a script that will automatically size things based on your viewport. Because remember, because of our orthographic projection, the height of this area is 10. And no matter what I do, the size of this, my quad will always be exactly the right height to cover it from top to bottom. But the left and right is obviously off. The other thing is you probably want things to overshoot the camera a bit, because right now, if we scrolled vertically, say, as soon as the star went here, it would instantly appear at the bottom, and that might be visual. So I really do like to have it a bit larger than the camera view. The other thing to note is you want to avoid having it different scale in different angles because it'll stretch oddly. So let's just call it 20 by 20 like this, and then hit play. That's pretty good. The speed at which you scroll is going to be based on the scale as well, because again, right now it's taking 10 seconds for a star to get from the right-hand side of this quad to the left. So the bigger you make the quad, effectively the faster your background will scroll. So you might want to make some adjustments there. Now, the thing that you're going to want to ask is, well, I don't want to have it scroll by itself. I want to have it sort of scroll based on the view, right? And again, here, if we take the camera, we move the camera, eventually we'll run out of stars. That's literally not an infinite scrolling Starfield, right? Oops. My reflex is to always hit Control S all the time. Let me just save the default scene over here, just so that I don't do that. Obviously, you don't want to do that. So how do we resolve this? Well, the easiest way to do it, and let's rename this quad to the Starfield. The easiest way to do it is we can take the Starfield and just attach it to the main camera. So the main camera is the parent of the Starfield. Now, if we move the camera, the Starfield moves with us. Oops, I'm moving the Starfield. If I move the camera, the Starfield moves with us. Now, it doesn't look like the stars are moving, right? Because relative to the camera, the stars aren't moving. So we've got the scroller, which is great, and I mean, it looks pretty. And we move the camera around. So, I mean, imagine you've got a situation. Let's say we've got a spaceship. I'm going to make a cube. Try to emphasize the point I'm trying to get here. Is we've got this cube. This is our spaceship. Yeah. Can I see this? Oh, why is it at 900? There we go. And the camera, we're going to center that way again. There we go. And the Starfield is centered there. Okay. This cube, which is our spaceship, this is the player. One thing you might want to do, if it's a game where you can sort of pan around all over the place with your spaceship, is just attach the main camera to it. Or again, if your spaceship rotates, it'll be kind of weird because the camera will rotate with it, which is not what you want. So in fact, you're going to want some sort of script on the camera that just follows the spaceship. For our purposes, this structure is going to be perfectly fine. So now, if I move the spaceship around, let me change to the 2D projection just because it's going to make things a little easier to work with over here. If I move the spaceship around, the camera moves with it, and also the Starfield moves with it. But you're not getting a scrolling effect with the motion. So how do we get that to go? In our Starfield, instead of using scroll UV like this, what if we figured out our absolute position in the game world and changed our background based on that? Like, what the hell am I talking about? What we want is when, oops, I don't want to hit play. When our spaceship moves, say 1 unit to the east, positive towards the X, we want, since the Starfield is moving with us so that it's always behind our camera and therefore looks infinite, what we want to do is scroll the UV in the opposite direction to give it a sense of movement as we go. Well, we can figure that out. Here, we're setting an offset based on the time, which is why we're getting, this sort of effect, which you may want depending on what kind of game you're working on. If you're working on like a shmup or a side-scrolling sort of shooter game, then this is going to be excellent for you, right? But if you want your character to roam around like a big empty area with arbitrary bounds and fly wherever he wants, that doesn't cut it for you. So in that case, here's what we can do. So let's make a different script, actually. I'm going to duplicate it, and we're going to call this, I don't know, follow UV, or it's like an absolute UV. We'll go follow UV. Kind of a poor name, but there you have it. We'll close the old one. We need to make sure that the name of the script matches the name of the file exactly. Spelling matters. Also, we have to make sure that we don't have 2 files of the same class. That would be bad. So here in the update, instead of offsetting things based on time, we want to offset things based on our absolute position. Well, we can get that, right? We can say we've got our transform dot position. This will be our local position, I think. Let's take a look here. I can't remember if it might default to, because there's a local position. So is this currently giving us our world position? Oh, we need to, on our Starfield, we need to, let's just disable the other script and put in the follow UV one. Now if I move this, there we go. Oh, we're adding. That's not what we want to do. We don't want to add, we want to set. And we're paused, which is not what we want. There we go. So now as I move to the right, the background is scrolling to the left. Let me put a little script on my spaceship. We're going to go to the spaceship, create script, new script, simple spaceship. All it's going to do, I just want it to respond to my key commands. So on update, I'm going to go fast here. This is not the point of the tutorial. We're going to say transform dot position equals new vector 3. We're going to feed it in x and a y. The 0 is going to, or the z is going to stay on the 0, but the x and y is going to be based on input dot get axis horizontal times speed get axis vertical. Spelling matters on those. And we're going to set a float speed equals 5. There we go. That should be okay. Oh, we missed our semicolon. Right. Unexpected symbol. There we go. Now, if I hit the arrow keys. Oh, we're setting our position. That's not what we want. Dot translate. Based on this. Oh, and we want to go times time.delta time. There we go. So now if I hit to the right, and we can watch our coordinates over here. There we go. So wow, we're so zoomed in that this motion feels very, very fast. Actually, you know what is making it feel faster? Because it's not actually changing that quickly. You can see here, especially if I reset it, we can see how long it takes us to get to 1. Right? Well, it'll take a quarter of a second. or it takes a full second to move 5 units. The background is scrolling much faster than our motion justifies. Also, it's not scrolling in the vertical thing here. But it feels like the background is probably scrolling too fast. And why is that? Well, it's because the Starfield has a scale of 20. So what we probably want to do is divide the amount of offset we do based on our own local scale. But you're gonna want a parallax effect, so you're actually gonna want some sort of variable in here. Let's go ahead and do that so that it takes our scale into account. So that way, as you change your scale, the position stays relatively constant. And now we're gonna put in the Y. So now it should be a lot slower. There we go. And actually, what's great about this? Take a look. Look at in here in our scene editor, right? This grid represents. Let me stop this. This grid represents the actual world coordinates. So where these two gray lines meet, that is the 0, 0 point. Watch the stars relative to those lines. You can see the stars look like they don't move, which means we're doing exactly what we want. The background is technically static, but we have this view, this quad, that moves with our ship that just shows us the area we're in effectively. And this is an incredibly lightweight solution for getting an infinitely scrolling Starfield with your view, which is kind of neat. And I was saying something about a parallax effect. Imagine that we had, let's introduce some more cubes over here. Create 3D object, cube. I'll just center it to start off with, and then I'll take it and just move it off to the side, and another one off to the side. So imagine these are other spaceships. Now they're obviously going to be static. Now as I move, their position is correctly static with the background, right? Because they're not moving and our stars are effectively not moving. But I don't think it looks quite right. And that's the reason is the stars in the background should not move because they're so far away, they really shouldn't move as much. So what we want to do is add in some sort of like parallax variable. And we'll say something like, I don't know, we'll call it how do we want to do it? Multiply or divide, what's sexier? Let's do a division here. So where the higher the parallax, the slower the effect. So we're going to do this, and then we're going to do a further division based on our parallax. So now the background will actually move slower than the objects in the foreground. So now you see what I'm saying? Now you get a sense of 3D right away, because the objects that are far away scroll less slowly, which is something that happens in real life. In fact, things in the background that are infinitely far away, or effectively infinitely far away, which in reality stars are, wouldn't move at all relative to your position. But now there's a really cool 3D effect. And in fact, as I mentioned, you could do multiple layers here. If we did have a transparent Starfield, and we had a second Starfield object, so we had two of them. One, the transparent one, just make sure it's slightly in front of the opaque background. And you gave the distance Starfield a higher parallax effect. We may want to make this public so that it would move even more slowly. Then what you get is a like super 3D effect. Can I do that? I don't think there's any alphas in here though. Alpha from Gate Grayscale. Actually, we might be able to fake this. Now we should have transparency. Let me change the Starfield material to use that transparency. There we go. I'm going to change the main camera so that it actually has a black background. Now everything should look the same, but what's happening is the background is actually transparent. Let me take this Starfield, duplicate it, call this one the front one, and it needs what? It needs a different parallax effect. So the back one, we're going to set to a parallax of 4. Will that work? Will that be all I need to do? There we go. So now we have the Starfield. Now you don't want to use the same graphic for both because it's stupid. It doesn't work right. You want a separate, different kind of Starfield for the front layer. But now it really looks like you've got a couple of different layers going on. And I think everything, yeah, because when you get close, when you use the same graphics, it just looks like everything is blurry, which is obviously not good. I think what you want to do for the one in the back, you want it to go even slower. Let's call it an 8. And the one in the front, make it a 4. Because I think slower is actually better. Anyway, experiment with different numbers, and you can get something that looks really, really quite cool. But again, don't do this thing where you've got the same kind of stars. Maybe your closer one, instead of Starfield, you want some sort of nebula, some sort of gaseous nebula thing in the front, and it'll look cool. But you do have, at this point, an infinitely scrolling Starfield. You will never run out of background no matter what you do. It'll always be there. And I think that's pretty cool. This sort of technique also applies perfectly fine to side scrollers, right? In that case, the far background could be like mountains, the close background could be some hills, and then you have your actual, platforming kind of stuff way in the front of all that. And again, you get this parallax effect that makes sense. Clouds, that's another thing you can have on a layer in your scrolling kind of setup over here. And it just works. Again, note you don't do this with sprites. Just because with a sprite object, you don't get the same UV control in exactly the same way, because they all share the same material. You can do it, I suppose, but this technique works perfectly fine. And again, works in 2D, also works in 3D if you want. But you have to make sure that, your scene is arranged in the proper way. Hope you enjoyed this tutorial. You can download this file over at my website, aquila18.com/unity_tutorials. Check the link down below. And as always, I appreciate any feedback and, like, subscribe, share, favorite, do all that kind of jazz. See you next time, folks. Bye-bye.